All right, here is the homework. I'm going to go over it. So if you notice, when you scroll down, you would get hints. So don't look at the hints at first and see if you can start without the hint. But then if you need the hint, you get the hint. So write a series for inverse tan of x squared. So I'm going to start by saying what we know. So now we know, whether that's in air quotes or not is a different story, but we know the series for inverse tan of x. We just did it in the notes. So we know that that series is x minus x to the third over 3 plus x to the fifth over 5 minus x to the seventh over 7, and so on. So therefore, if we want to find the series for the inverse tan of x squared, I'm going to substitute. I'm going to plug in x squared every time I see an x. So this is going to become x squared minus, this is x squared to the third. So that's going to become x to the sixth over 3. Plus this is going to be x squared to the fifth. So this is going to become x to the 10th over 5. X squared to the seventh, so x to the 14th over 7, and so on. There's my series, now my general term. So this is even weirder than just having the odds. Now we have, it's not the evens, it's every other even. So there's a notation for that as well. This one doesn't come up as often, but if we have to write a number to express every other even, it's going to be 4n plus 2 is going to be the power of x. I would never put that on a test. I don't think you would actually have to know that for the AP test, but we'll see as we start to review. But that is the notation. I don't know maybe if you figured it out yourself or not, for every other even number. So the top power is going to go every other even. I'm going to have an alternator as well. Running out of room. And on the bottom, we have the odds, 2n plus 1. So let's see how this works out in terms of our powers or our numbers for n, our values for n. If I start n at 0, we should be in a good place. Starting n at 0 will mean x to the second is first, and 1 is first on the bottom, and that's good. And then here I want my first term to be positive, so I can just have n be the power of the alternator. Beautiful. Okay, number 2. This is we're going to manipulate a series that we already know. We're going to take what we know. So we're going to take the series for inverse tan of x, which I have written right up here that I'm going to use. And I'm going to divide every term by x. So this is going to equal, hold on, I'm going to put a line. This is going to equal this series up here, but every term is going to be divided by x. So that's how this is going to work. It's not like where I just added 1 to the series and I could just, or subtract 1 and I could just cancel the ones. This whole series of inverse tangents is going to be divided by x, which means every term. So this is going to become x over x minus x to the third over 3x plus x to the fifth over 5x minus x to the seventh over 7x. And so on. So let's reduce this. We're going to have 1 minus x squared over 3 plus x to the fourth over 5 minus x to the sixth over 7, and so on. So our general term, we are raising x to all the even powers. So we're going to have 2n plus 1. The denominator is all the, I didn't mean that. 2n. The bottom is going to be all the odd powers, so 2n plus 1. And I'm going to have an alternator. So let's check out n. If we have n start with 0, then I'm going to get that first term to work out. And I can also let this be n, and that gives me a positive first term. Okay, number 3. So this one I would not see. I don't expect you to see that yourself. that we are going to rewrite 1 over x as 1 over 1 minus 1 minus x. Okay, I'm pulling that definitely out of thin air, and that's a tricky one for you to actually have to do by yourself. I don't think they would require that. So this is geometric. I can substitute. I'm not going to. I'm going to think about this as a geometric series, actually. Did I write down substitution for the hint? No, okay, good. Okay, so number 3, I'm going to consider this to be just geometric. A is 1 and R is 1 minus x. So I'm going to have the series is 1 plus 1 minus x plus 1 minus x squared plus 1 minus x to the third, and so on. And we're going to end up with the general term of just 1 minus x to the n, and going from 0 to infinity. Okay, number 4, I wrote down as rewrite and use substitution. So I'm going to do a similar rewrite to what I just did. That's why I thought I did the first one first to tell you the exact rewrite, and then I'm hoping you maybe were able to, I don't know, do something similar. So I'm going to rewrite and use substitution. So since I know we know the series for the natural log of 1 plus x. We know what this series is. This is x minus x squared over 2 plus x to the third over 3 minus x to the fourth over 4, and so on. So I'm going to rewrite my series, the natural log of 1 minus x. I'm going to rewrite that as the natural log of 1 plus negative x. And then I'm going to be able to use substitution. So since I know that the natural log of 1 plus x is this series, I need mine to be the natural log of 1 plus something as well. So I'm going to rewrite the one I was given to find as the natural log of 1 plus negative x, and then I can just substitute. I can substitute negative x in for all of my x's. So this new series is going to be negative x minus negative x squared over 2 plus negative x to the third over 3 minus negative x to the fourth over 4, and so on, which I will reduce to negative x. This will become a positive x squared, but we're still minus. This will become negative x to the third. This will become positive x to the fourth, but we're still minus. So notice my terms do not alternate. So my general term for this is not going to have an alternator. It's just going to be, let's see, how do I want to say this one? Because I don't alternate and I want to make sure that every term is negative, I can just say my series is negative 1 times x to the n over n. That would be fine. That way I take that negative out of the formula altogether. And I don't worry about multiplying by negative 1 at all. And n is going to go from 1 to infinity. There are obviously other ways to write that general term, but that's probably what I would do. All right, let me give myself space. Okay, number 5, since I don't have a whole lot of room. If f of x equals this series, write the series for the integral of f of x. So I'm going to write this out. F of x equals 4 plus 4x plus 4x squared plus 4x to the third. So the integral, I'm going to integrate both sides so that the integral of f of x is going to equal 4x plus 4x squared over 2 plus 4x to the third over 3 plus 4x to the fourth over 4, and so on. So let me reduce this. So this series is going to be 4x plus 2x squared plus 4/3 x to the third plus 1x to the fourth. This is gross. So I shouldn't have, I'm looking at it and thinking, how am I going to write that general term? You know what? I shouldn't have reduced. Remember before when I was like, sometimes reducing makes it more complicated? This reduced answer is more complicated to figure out a general term. So I'm not going to write it reduced. I'm going to keep it like this because this general term is not that hard. This general term is just going to be 4x to the n over n. Because the power of x and the denominator match, so that works out. And if I start it at 1, we end up with it all working out perfectly. So there's my general term. Okay, hopefully that makes some sense. We're going to do a quick check on Monday. What's that going to look like? I don't really know yet. Probably similar to what these look like. I'm also going to ask you something about a geometric or whatever. You'll have to write a geometric series as well. But I will give hints and make sure you can follow along as you go.